So, good morning, learners. Welcome to today's lesson. And our math lesson today, we continue dealing with decimals. Decimals, but we are rounded off. We are doing conversion of fraction to decimals. Just remind you what we did. How we convert fraction to decimals. Like, for example, we've given a quarter. We are told to convert this a quarter to a decimal. We say the denominator outside, then the numerator inside, then you divide. 4 cannot get into 1, so you say 0 point, you add a 0 there. You realize 4 can get into 10 2 times, you get 8, you subtract the remaining 2, you add a 0. 4 gets into 25 times, then you subtract there, you get 0. Meaning that a quarter converted to a decimal becomes 0.25. So that's exactly what we were doing in our previous lesson. Now in our today's lesson, learner, we are going to see what we call recurring decimals. Now in your working in that exercise 50, you might have come across some recurring decimals where a decimal will not come to an end, it continue reoccurring every time you divide, you find it's repeating itself. That is what we mean by recurring decimals. So we are going to deal with recurring decimals, meaning that they keep on repeating themselves. No matter how much you divide, they still continue repeating themselves. Now, the kind of example I gave you here, like for example, convert a quarter to a decimal, say 4, and then inside we have 1. 0.0, 2 times, you get 8. You remain with 2, you add a 0. 5 times, you get 20. So what we mean here that 0.25, you can see it as an end. A quarter can be divided to an end to give you 0.25. So this type of a decimal, we call it terminating decimal. Terminating decimal. Meaning that it can come to an end, terminating decimal. So the opposite of terminating decimal is what we're calling recurring decimals. Recurring decimals. So we are going to have one example, or several examples for that matter. You can have a number of them. Like for example, you are given convert a third to decimal. Convert a third decimal. How do you do it, learner? You try to look at it in this direction. So a third, we said the denominator should be inside, that is 3, and numerator to be inside there. So learner, 3 cannot get into 1, and so we say 0 point, you add a 0 there. 3 times, you get 9, subtract, you get 1 there, you add a 0. 3 times, you get 9. Remaining 1, add a 0, 3 times you get 9, 1, add a 0, 3 times you get 9, 1, add a 0, 3 times you get 9. You will find that this keeps on recurring, that it's not terminating, it's not coming to an end. And so in this case, we say this is an example of a recurring decimal. Now, in an exam, you can be given this, and there's one thing that you use. If it continues repeating itself like that, of course we call it non-terminating, and so there is a symbol that we use to show that there is a certain number that is recurring. Like for example, which number is recurring in this answer? 3 is recurring every time. So there's a symbol you can put on that particular number, which is recurring, the one that is repeating itself. And so the symbol looks like a dot, a dark dot on top of that number. And so for us to be able to write this, if, for example, you write for me 0.3 in an exam or in any question, I will know that 3 is repeating itself. So that you're just avoiding to write it so many times here. You put a dot on the recurring number there. So we call this what we call a recurring decimal. When you symbolize using that dot, then we can still know which number is recurring. Let's have another example, Anna. 1 over 12. We want to convert 1 over 12. Convert 1 over 12 into a decimal. Convert 1 over 12 into a decimal. And so 12 is outside, 1 is inside. So 0.0 still cannot divide. What did I say, Lana? If after adding the first 0, the number is still small. The number outside is small, cannot divide. I mean, the number outside is bigger than the number inside. You need to add a 0 there and a 0 there. So how many times? Lana 8 times. You get 96. You get 4. 9 minus this is 9 minus 9 is 0. So you add a 0 there, Lana. How many times? 3 times. You get 6. You remain with 4. Add a 0. 3 times. 36. You remain with 4. Add a 0. 3 times. 36. You remain with 0. And so you remain with 4. So in this case, you realize that there is a number which is repeating itself there. So your answer in this case is 0.08333 3 times and so many other times, meaning that every time you subtract you get 4, and so 3 is going to repeat itself. So where do you put that dot, Lana, I told you? So you only put that dot on top of the number that is recurring, not the first number, as in this case. You only put it on top of the number that is recurring. So is 0 recurring? No. 0 recurring? No. 8 recurring? No. 3. Is 3 recurring? Yes. So you put on top of that number. And then you don't write it like that. You come and now write 0.083 recurring. So the 3 is the one that is recurring, and so you put on top of that number. So your answer is not this one. Your answer is 0.83 recurring. So the 3 is the one that is repeating itself. So that's where you put the dot. Let us maybe do another example and see what you are going to get. Convert 1 over 22 as a decimal. Convert 1 over 22 as a decimal. One convert 1 over 22 as a decimal. So obviously, the denominator outside, the numerator inside. So the 2 cannot get into 1 because 1 is small. So 0 point and add a 0 there. The 2 is still bigger than this number. You add a 0 there. So first add a 0 on top and then inside there. So 22 and then we have 100 there. So how many times, Lana? 4 times. 4 times you get 88. You borrow 1, you remain with 9. And 10 minus this is 12, 2. So 9 minus 1 is 12. So you remain with 12. 22 and 12, this one is smaller, so you add a 0 there. So how many times, Lana? By 6 is 1, that's 2. So by 5, 110. 0. By 5, you get 110. Maybe 0, 1. You add a 0. Lana, how many times? 4 times, you get 88. You remain with 12. You add a 0. How many times, Lana? 5. You get 110. It is 0, 1. You add a 0. How many times, Lana? 4 times. You get 88. Subtract, you remain with 12. You add a 0. 5 times. You get 110. So we can stop it at that point, Lana, and see, come to our answer now. Answer is 0.454545. So we're going to ask ourselves, in this case, how many numbers are repeating themselves? You realize that 2 numbers are repeating themselves. Which number and which one? Digit 4 and 5 are repeating themselves in that order. 4, 5, 4, 5, 4, 5. And so, our answer is going to be, we are going to put the dots on the numbers that are repeating, even if they are 3. Even if it was 0.383838, you're going to put them on the 3 numbers. So, which numbers are repeating? 2 numbers, 4 and 5 are repeating themselves. So, we are going to put the dots on those 2 numbers that are repeating themselves. And so, our answer is going to be 0.45 recurring, 0.45 recurring. So, that becomes our answer. If in an answer you get a question like 0.484484484, you realize that 4 is repeating itself. So this number, and this number, you put the dots on those numbers, the ones that are repeating themselves. So that is what we call recurring decimals. So I want you to attempt an exercise there. That is exercise 51. Exercise 51. I want you to look at that exercise. I'm going to do one for you. Exercise 51. We are going to do number 1, 2, and 3. Now I want to explain what number 3 means. Given that 1 over 9, number 3, given that 1 over 9 is 0.111 carry, 0.111. Use this pattern to convert the following fractions to decimals without any further calculations. So if 1 over 9 is 0.1111, what about 4 over 9? You realize this is going to multiply. So 4 over 9 is going to be 0.4444. So you just look at this number. So the number that is going to repeat is the number on top in each question. So I need to attempt number 1, 2, and 3. Number 1, 2, and 3. Meaning that if it's 8 over 9 now, 8 over 9 is going to be 0.8888. So you just look at the number on the numerical side. That's the one that's going to be recurring. So you attempt number 1, 2, and 3. Exercise 51. Number 1, 2, and 3. That is on page 72. That's the work that I expect you to do. Do it well, calculate, ensure that you divide and divide well. I'm sure you're going to get the numbers correct. So until next time, learner, I want to wish you well, have a blessed day ahead, and do the work and forward to marking. God bless you.